Hello everyone, I'm Nitin, and in this video I'll be discussing what is a peer-to-peer architectural model, what is an overlay network, unstructured peer-to-peer network, structured peer-to-peer network, finally advantages and disadvantages of the peer-to-peer architectural model. So let's get started. What is a peer-to-peer architectural model? So in this model, two or more machines or nodes equipped with their own processing power are connected and share resources without requiring a separate server. All nodes in the network have equal responsibilities and privileges for processing tasks and data, where tasks are distributed equally among all the nodes and communicate directly with each other. Each node provides resources to the network and consumes resources that are available in the network. Therefore, each node can serve as either a client or a server at a given time. The peer-to-peer distributed system is represented by the diagram below, where several nodes are connected with each other in order to provide important functionalities of a distributed system. If we want to learn the peer-to-peer architectural model in more detail, we need to know what is an overlay network. An overlay network is a network that is built on top of another network, which is called an underlay network, meaning that an overlay network is supported by the infrastructure of an underlay network. All nodes in an overlay network are connected with one another by means of logical or virtual links, and each of these links correspond to a path in the underlying network, which are normally implemented as tunnels. Multiple overlay networks can exist on top of the same underlying network, where each implementing its own specific services. Why do we build overlay networks? The aim of an overlay network is to enable new services or functions without a complete network redesign. An overlay network decouples network services from the underlying network by encapsulating one packet inside of another packet. After the encapsulated packet has been forwarded to the endpoint, it is de-encapsulated. Most popular examples of overlay networks are Internet, peer-to-peer networks, virtual private networks, and voice over IP services like Skype. Let's look at the design of a peer-to-peer overlay network. Peer-to-peer networks generally implement some form of virtual overlay network on the top of the physical network, where the nodes in the overlay network is a subset of the nodes in the physical network. Data is still exchanged over the underlying network, but at the top layer, peers are able to communicate with each other directly via the logical overlay links, each of which corresponds to a path through the underlying physical network. Overlay networks are used for indexing and peer discovery and make the peer-to-peer system independent from the physical network topology. Based on how nodes are linked to each other within the overlay network and how resources are indexed and located, we can classify peer-to-peer networks as unstructured or structured networks. Now we look at the unstructured peer-to-peer network and its characteristics. Firstly, it does not impose a specific structure on the overlay network by design. Secondly, unstructured peer-to-peer networks are easy to build and scale up or down. Next, it has a relatively higher churn rate, meaning that a large number of nodes frequently join and leave the network. Next, searching for any resource or data in an unstructured network is inefficient, and it does not ensure that such queries will always be resolved, in particular when the resource is extremely rare. Next, nodes perform searching in the network for required resources, mostly using flooding or random walk method, meaning that if a node wants to find a particular resource or file, then the search query must be flooded through the network to reach as many nodes as possible that may be a potential target for the search. Finally, some examples of the unstructured peer-to-peer network. Now we look at the structured peer-to-peer network and its characteristics. Firstly, it organizes the overlay network based on a specific structure or topology and algorithm. Secondly, structured peer-to-peer networks are difficult to build and scale up or down. Next, it has a relatively lower churn rate, meaning that a small number of nodes frequently join and leave the network. Next, searching for any resource or data in a structured network is relatively efficient. It ensures that search queries will always be resolved, in particular when the resource is extremely rare. Next, nodes perform searching in the network for required resources, normally using a distributed hash table known as DHT, which stores key value pairs, and any participating node can efficiently retrieve the value associated with a given key. Finally, some examples of the structured peer-to-peer network. Next, advantages of the peer-to-peer architectural model. Firstly, resource sharing. In peer-to-peer architecture, resources are shared among all the nodes, and nodes can provide and consume resources at the same time to share the load. Secondly, fault tolerance. Peer-to-peer architecture is very resilient to faults. Nodes work independently with each other. Therefore, if some nodes go down, then their workload can be taken over by other nodes and the distributed system continues its working as normal. Next, scalability. Peer-to-peer architecture has one of the best scalability features. Whenever the workload increases, a number of nodes or resources can be easily added. Finally, cost effectiveness. The overall cost of building and maintaining a peer-to-peer network is relatively inexpensive. The setup cost has been greatly reduced due to the fact that there is no central configuration. Finally, let's look at disadvantages of the peer-to-peer architectural model. Firstly, failure handling. We already know that fault tolerance is one of the biggest advantages of peer-to-peer architecture. However, handling of faults and failures is a complex process due to a large number of nodes in the system and only few nodes fail while others continue to function. Secondly, management overhead is another challenge of peer-to-peer systems due to the message-based communication amongst a large number of nodes and their components. Additionally, monitoring, logging, load balancing, and failure handling functions could also increase the management overhead. Next, security is another big challenge of peer-to-peer systems due to a large number of nodes and components separated geographically and could be more vulnerable to security breaches. Finally, backup and recovery. In peer-to-peer architecture, data is normally stored and managed on individual nodes. Therefore, backup and recovery process is very complex. This concludes my presentation and thanks for watching my video.